everyone. I'm Jeff. I'm the co-founder and head of engineering at Donut. And I'm here to talk to you a bit about button best practices and just more generally interactive messages and some things you can do to make sure that your message interactions function smoothly. So in order to do that, we're going to use a real life example from Donut. So I'm just briefly going to tell you a little bit about Donut. Donut is a tool and an app for building culture at your company. And to that end, one of the features of Donut is that you can automate a coffee or lunch roulette program. So basically, you add Donut to a channel, and then on a weekly basis or every couple weeks, Donut will take everyone in that channel, put them together into pairs or small groups, and then send them a message to say, you guys are buddies for the week, find a time to go grab coffee or lunch together. So what you see here is a message sent to my co-founders, Dan and Kippy. This is a MPIM, a multi-party IM, where Donut's telling them, hey, find a time to grab coffee or lunch. So then what happens next is they chat, they find a time, 3 p.m., I don't know what day that's supposed to be, Blue Bottle, they meet, they have a great time, they become best friends. And then at the end of the week, this is where we bring in some buttons. Friday afternoon, Donut sends another message to ask them if they had a chance to meet this week. And so you see there we have 3 buttons they can click on, yes, no, or it's scheduled. And then let's say that Dan clicked yes, so then you see there Dan said that you met. And Donut sends a follow-up message checking to see if they have any feedback. So this is the example we're going to be working with for the next 20 minutes. Diving really deep into the nitty-gritty details of what's going on there. So let's take a closer look at what's happening there with that interaction using those buttons. So when Dan clicked on the yes button, a few things happened. Number one is that the buttons went away, and that's important because with this question, it doesn't really make sense to take multiple answers to that, right? It's a simple yes or no, maybe question. And we just want a single answer. So once they click, we get rid of the buttons, and we replace it instead with a new attachment that reflects the response that was given, right? It says down below, Dan said that you met. And then, of course, we're sending this follow-up message to ask for feedback. And then behind the scenes, we're going to record the response that was given in our own database so that we can keep track of what's going on. So that's the breakdown of what's happening here. So let's go behind the scenes to look at what's happening here with these buttons. So first of all, just real quick, if you haven't used buttons before, I'm just going to run down the basic life cycle of a button as used in this case. So the first step, obviously, is that the app needs to send a message that contains buttons. And there's a number of ways to do that. You could use the web API, chat, post, message. You might do it in response to a slash command. There's at least 5 or more other ways that you can send a message with buttons in it. In our case, we're using chat, post, message to send those messages. And just to take a quick look at the JSON, this is the JSON to represent the attachment that has the buttons in it. So it's pretty simple. There's 3 actions there. Each one has a name, text, which is what shows on the button, type button. And I've left out something important for now, which is the callback ID. So we're going to come back to that. So the second step after we've sent the message that has buttons in it is that someone in Slack clicks on one of those buttons. And immediately after that, Slack sends a request to our server, including a payload. That payload tells us everything we need to know about what's going on, who clicked the button, which button did they click. And I should have put up there as well that the callback ID that we specified in the attachment also gets included, which is how we can figure out which set of buttons was clicked. And then the fourth step is that the app server, the Donut server, needs to send back a response. And there's 2 things you can do at this point. One is you can send an empty response, in which case nothing happens. Or the second option is that you can send back in your response a updated version of the message. And so with this, you can actually, you have full flexibility. You can completely replace the original message if you want, or you can keep some of it and replace pieces of it. So this is the way that we're going to remove the buttons when a button gets clicked. Okay, so we're going to start to put together some code, for a simple web app to actually do this. But before we get into the code, we talked about the fact that we're going to record in the database what action was taken. And so I just want to introduce the idea here of a meeting model. So we're going to have a database model that we're calling meeting, and this corresponds to the meeting between Dan and Kippy. So there's a number of attributes on the model, including who the participants were, when was this meeting, what's the state of it, did we introduce them yet, have we sent those buttons out yet, did they respond? And in addition to that, the class for this model is going to be responsible for a number of things. It's going to be responsible for sending the message in the first place that has the buttons, and then importantly for this example, this model is going to be responsible for handling the payload when it comes in. So just coming back now to the attachment JSON, I said we were going to come back and look at the callback ID. What we use for callback IDs in Donut is we basically just take the name of the model, the ID of the record, and we stick that together, and that's our callback ID. And that way, whenever someone clicks a button, we can just grab that callback ID, parse that, and go find the record that this button is associated with. Okay, so let's turn to some code here. This is Ruby. This is Ruby on Rails, but I tried to make this sort of generic, and nothing that's happening here is very specific to Ruby. You could do this in a lot of languages and frameworks. So what we have here is a controller. We're defining the endpoint where Slack is going to send the payload when a button gets clicked. So there's a few things to highlight here. Of course, you need to pull the payload out of the parameters. And as a couple people have mentioned today, you got to remember to parse that because it's a raw JSON string, so you got to parse that out. And then, as I said, we're going to parse the callback ID to pull out what is the model that this was associated with and what's the ID of the record. Once we have that, we can go ahead and grab that record out of the database, load it from the database. And then, as I said before, the model is responsible for basically taking care of everything else. So we've got a method here on the model called handle message action. We're giving it the payload, and we're expecting it to give us back the updated version of the message. So that's the message where we've taken away the buttons and put in its place the message that Dan said that you met. And then we're giving that the response back to Slack so that the message will ultimately update. So let's turn now to the model, the meeting model, and that method that we were calling, handle message action. Pretty simple. We're starting out by going into the payload and pulling out the name of the action. So that was yes or no, or it's scheduled. We're pulling out the ID of the user that clicked on the button. And then, as I said, we're just going to store that somewhere on this record to keep track of who clicked what and what they clicked. And then we're going to send that follow-up message asking for feedback, and this is ultimately using the chat post message method to send that extra method. And then the last step is we need to assemble the new updated version of the message. And you can see that we're going into a field on the payload called original message. So conveniently, we get sent along the entire original message that had the buttons in it. So we can go into that, pull out the text because we don't want to change that. And we're going to use the text from there. And then we're assembling a new attachment. So again, based on the action and the user, we assemble a new attachment. That's where it's going to say, Dan said that you met. And we return that. Okay, so this, pretty good, pretty simple. So let's see it in action. Button click, spinner, and an error message. So something went wrong there. And there could be a few things. Maybe you didn't put the right URL into your Slack app. Maybe your server's not running. But probably what this means, if everything's configured properly, is that you took too long to respond. So you have 3 seconds to respond back to Slack when a payload is sent, and if you don't respond within 3 seconds, this is what happens. And so even though if you wrote the code we just did and you run it on your dev environment, it's probably going to work fine, and maybe you go to production with it and it works pretty good most of the time, but you're going to start to see this as you start sending more buttons out there. So let's take a look at why we're going over 3 seconds. And so what we have here is a timeline, starting with the click of the button, and on top we have the Slack domain, the Slack client, and its servers, and on the bottom is the Donut servers. So the first step here is a button gets clicked, the request gets sent over to Donut, and then we're doing a number of things here. We're going to the database, right? We're loading a record, loading that meeting record from our database, and then we're also updating it to save the button click, right? So that's a couple queries to our database. And then we're going to the Slack web API to send a message, and we need to wait on that response to come back. We need to do all of that before we can finally get back to Slack with our response where we update the buttons. So you can see why most of the time this will probably be under 3 seconds, but with network time, maybe the Slack web API is being a little sluggish at the moment, this can easily get over 3 seconds. So we want to fix this. There's a couple ways to do it, and the one that we use is a background worker. So if you're not familiar with the idea here, the idea of a background worker is you have another process running in the background that can take tasks off of the web process, so you don't need to have those happening synchronously in the web process. Instead, they happen asynchronously in the background. So we're going to use there's background worker frameworks in many languages. If you were in here for Ankur's talk, he talked about using JavaScript promises. This is a different approach to the same problem. So let's take a look at what this would look like with a background process. So the idea is we're going to take the work that involved the database and the work that involved the Slack web API and move that down into a background process so that the web process can basically just get the payload, put a job in our job queue so that the worker knows what to do, and then just assemble the new version of the message and send it back. And so this is almost guaranteed to return in under 3 seconds because you're barely doing anything. And then the worker can take its time to finish up the rest. So let's go back to the code and see how we would adjust things for that. This is the controller again, and not much has changed. The big change here is that we're no longer going to the database to load the meeting record. Instead, what we're doing is we're calling handle message action has now become a class level method on the meeting model, and we're going to call that and expect that to return the response. So we're not going to the database yet at this point. Turning over to the meeting model now, we've basically split what used to be that single instance method into 2 methods here. So on top we have a class level method that's being called from the controller, and that's going to run in the web process. And then on the bottom we have the instance level method, and the idea is that the background worker is going to pick up the job from the queue, and load the record, and execute that method. So you can see the first step here at the top in the first method is to put a job in the queue. That's so that the worker can go ahead and do its thing. And then all that's happening here is we're assembling the new version of the message as before. We don't need to go to the database, make any external requests or anything, and then that gets returned. And then in the background, asynchronously, we do the rest of it. The same as before, we're saving the action. Let me go back. Save the action and send the follow-up message. So let's see the result. Great, it works. Perfect, we've solved all the problems. So now that it's working, let's introduce some more issues. Suppose that the updated version of the buttons, after you click it, suppose that we want to include in there some bit of data that needs to come out of our database. The problem here is that since we've pushed the access of the database down into the background, we no longer have access to anything from our database at the time when we're assembling the updated version of the buttons. Well, if you've worked with buttons before, you probably know that Slack has a good solution for this, which is the response URL. So along with the payload, you get a URL called the response URL, and you can make multiple requests to this URL, I think within 30 minutes after receiving it, to update the message asynchronously. So we're going to use that from the background to update our buttons instead of updating them in the first place. So this looks pretty good, but we've actually now introduced a new problem, which is that when those buttons get clicked, they get disabled, which means they can't be clicked again. And they're disabled until the response comes back from Donut. So that's good, they can't be clicked again. But then once the response comes back, they actually get re-enabled, and they'd be able to be clicked until the worker comes around and uses the response URL to get rid of them. And that's not good. Like we said before, we only want to allow a single click on these buttons. So let's take a look just at what that would look like. So there was a click, and now they're re-enabled, and then finally the worker comes around and updates it. I'll just let that play again. There's a click, they're disabled, now they're re-enabled, and then response URL updates the message, and then there's the follow-up message. So that's not so good, because there's a time in between there where they could click the button again. So the solution's pretty easy. Instead, we're just going to update them twice. So we'll go back to what we were originally doing, where we update the message to remove the buttons in our initial response. And at that point, we don't have access to the database, so we won't include that bit of information. And then a moment later in the background process, we use the response URL to update again. And then this time we can include that bit of info out of our database. So here's what that would look like. There's a click, the buttons go away, and then there's a second update where it adds that extra bit that says, it's the first time you met. And then the follow-up message gets sent. So that's great. And this is sort of artificially slowed down so you can see it. So here's what it would look like in real time. Pretty seamless. There's no opportunity there for extra clicks. Everything's good. So let's go back to the code. This is now a lot of code to put on the screen, but basically all of it is the same as before. I just want to highlight this is actually not different than before. It's the same, but we just want to be aware of the fact that this now, in the first method, this is where we're setting that temporary version of the updated message. And then down below, using the response URL is where we can assemble the final version. And at this point, we have access to that info from the database. And then we're pulling the response URL out of the payload and making a request to the URL. Okay, so everything's working great until this happens. So what's happening here is we send the message, the button gets clicked, everything goes great, and then somehow a day later, we get another payload sent in saying that someone else clicked the button. Now that shouldn't really be possible because we got rid of the buttons, right? Well, it happens, even though it should be impossible. It probably has something to do with multiple clients out there. Remember, we're sending these messages to MPIM, so there's two different users who can see them. So the question is, if when that second button press comes in, what is our code going to do? It's not going to be good because it's going to send the follow-up message for a second time, which we don't want to have happen. So we can solve this pretty easily by just popping in a return statement, right? So before we start to actually process the action, we just check to see if we already processed it. Easy. Or if you're like me, instead of returning, you can raise an error. It's great. So we fixed that, but here's another problem. You could get two button presses that are more or less happening at the exact same time, and this is also something we've seen happening in the wild. And the problem here is that if they're happening at basically the same time, then they're both going to start processing before either of them finishes processing, and then they both end up getting processed. So how can you fix this? It's pretty simple. If you're using a database that supports record locking, you just need to acquire a lock on the record before you start doing any processing. That way, only one of those clicks can get processed first, and then the second one will raise the error. Great, so now everything really is perfect. No more problems. So let's just summarize that. For the callback ID, if you're working with database records, you can use the model name and the record ID for your callback ID, and that way you can find the record right off the bat once you get a payload. 2 is that you want to respond, if you're doing something where it only makes sense to allow a single button click, you want to make sure to respond as soon as possible and get rid of the buttons. That means don't go to your database, don't make any external requests. Instead, use a background process to do any additional tasks involving the database, external requests, and use the response URL at that point to make any further updates that you need to make after the initial update. 4 is to make sure to always check the state before you process, because you may get unexpected double clicks. And 5th is to use database locking to avoid double processing as well. One last note is you might be wondering, what about interactive menus? Right, so this was all about buttons, but menus are another great interactive feature. Basically, everything I just said applies exactly the same to menus. The structure of the attachment JSON is a little different, and the structure of the payload is a little different, but other than that, all the principles I just talked about apply exactly the same. And then what about dialogues? Dialogues are another great interactive feature. Dialogues work a little differently, so everything I said applies sort of, but maybe in a slightly different combination than what I described. So I'll tell you about that next year. Thanks, that's it.
That's great, thanks, Jeff. I think we have time for one question. Anybody? Nobody? All right. Thanks, Jeff. Much appreciated. I'm still Brian. I dropped the dress shirt. Huge thanks to everybody for attending. SPEC, our first ever developer conference. Should we do it again? Awesome. Huge kudos and thanks to all of you, to our customers, our partners, our developers. That's actually a mixed group. Our customers are our developers are our partners. All of our partners are also our customers. So it's all of you that are helping us build this together. I wanted to thank our team also. People have worked weeks on end, an awesome event staff. Can we give them a quick round of applause? I don't usually do this, but one key member of our team wasn't able to be here today. Our head of marketing kind of had a little bit of a busy day. While we were doing this, she was doing that. That's Lily Jane Stallsmith, born this morning, to Cece Stallsmith, our head of marketing. So congratulations, Cece. 2 last notes. Number 1, feedback. You're all going to get a survey. Please fill it out. We want to know what else you want to hear, what worked about today, what you want to see next time, because there will be a next time. And number 2, there's a reception out in the hallway right now. Food, drink, photo booth, and importantly, a lot of our team is here. Our team has been watching all day long, both here in the rooms and remotely. It's amazing to get all the feedback live, all the questions, all the comments, all the interactions. So please bring your feedback to us. Please join us, and thank you very much for coming.